Okay, in this question we are asked, what is the pH of a buffer made from 0.22 moles of HCNO, we're given the Ka for that, weak acid, and 0.410 moles of NaCNO in 2 liters of solution. Alright, so we're told that it's a buffer. Okay, now remember, a buffer is a combination of a weak acid and its conjugate base. So let's identify those 2 components. This right here is going to be our weak acid, and we know that because we're given the Ka. Now the weak or the conjugate base is in this salt right there, because if you think about it, that is an ionic compound that when I put in water is going to break apart into its component ions. So I'm going to get the sodium ion and I'm going to get the CNO minus ion. Right? So now I've got the components that are involved in the equilibrium of this weak acid. So a weak acid, when it behaves like an acid, it reacts with water, and it's going to do so in a reversible way to give me the conjugate base, CNO minus, and a hydronium ion. Okay, so there's my weak acid, and there's the conjugate base. And so I have a buffer. And whenever we have a buffer, remember we can use the Henderson-Hasselbalch equation to calculate the pH, and that's what we're asked to do. So according to Henderson-Hasselbalch equation, the pH is equal to the pKa plus the log of the concentration of the base over the concentration of the acid. Alright, well, we've already identified what our acid and what our base is, so we can just kind of plug and chug at this point. So the pH is going to be equal to the negative log of the Ka, so that's 3.5 times 10 to the minus 4, plus the log of the concentration. Now I want to point something out here. We're given moles in the problem statement, but we don't have to convert those into concentrations because both of these would be going into the same volume, 2 liters. So that would be like dividing this by 2 and dividing this by 2, one on top of the other. So it would just cancel out. So we can just go ahead and put number of moles into the Henderson-Hasselbalch equation. So the base is this part, so 0.410. And then the acid is the HCNO, so 0.220. Okay. And then you just plug that into your calculator and you get an answer. 3.73 is the pH of this particular buffer.